Right, so stores sell small and large ice bags. Small bag costs this much, while large bag costs $4.50. Define the variables and state the implicit constraint. So you have to let x and y be something, and x would be number of small bags. That's half a mark. Number of large bags. That's half a mark. And the implicit constraint is x comma y is greater than or equal to 0. Easy peasy. Please don't lose marks there. Okay. Write the inequality that would indicate that the store owner would like to sell at least $500 worth of ice bags. That tells you that there's some sort of inequality there. So at least tells you that it's going to go like this, and then the 500 will be there. And then on this side, because it's talking money, we're going to use these as our coefficients. Okay, so it's 275x plus 450y. It's okay if you just put 4.5. It doesn't have to be 4.50, but that's what you would get. So today it's all or nothing. Okay, there's no, in fact, that's how I'm going to mark it. It's all or nothing, but then I'm going to use your inequalities and see if you graphed it correctly based on your inequality. Okay? Write the inequality that would indicate the store owner can store at most 100 bags combined. So at most 100. Okay? So all you would do here is x plus y, because these represent, right, x and y represent the number of bags, so the combination of them has to be less than or equal to 100. Next, write the inequality that would indicate that the store owner carries a maximum of 45 small bags. Okay, so that would be like that, maximum 45, and we're only talking about the small ones in particular, so we only use the variable x in this case. 1 mark for that. Next, a minimum of 50 large bags. A minimum. So you would face it that way, 50, and it's only talking about the large bags, so you would just go y there. Another mark for that. Okay. Later we're going to graph these. Right now it's just you know how to write them, because if you don't know how to write them, it's a totally different story, right? Okay, given this inequality, answer the following. Which region would you shade using regular shading? Okay, so all you need to do is rewrite that. So I'm just going to divide everything by -2. That's all you need to do still. And when you divide by a negative, I don't know if you remember, you flip the inequality the other way. So it's -5 over 2x minus 15. Quite honestly, this is irrelevant. It's this part that you want to focus on. Y is less than, we know that it's a dashed line. The true region would be below the line. Okay, that's what we care about the most. Where is the true region? And if it's regular shading, we shade where the true region is. So the answer is below. Okay, I asked you to show work. So this would be a mark where you show the work. This would be half a mark actually, because it's quite easy once you've done the work to determine this. Okay, so would this be part of the solution? Let's see, we plug that into that. So you have to be careful. -2y, y is -15, greater than 5 times -1 plus 30. Oh, you can't see. Sorry. I'm getting used to my new setup here. Thank you for that. Sorry, let's do this again. So -15 goes into y, right? Goes in here. And the x goes in here, plus 30. And then you just clean this up. So -2 times -15 is positive 30. That's supposed to be greater than, this is -5 plus 30, that would be 25. And this is true, right? True, therefore it is a solution. There you go. All right, write the inequality for the following graph. Assume regular shading. That's actually important. If we're doing regular shading, that means that the shaded area is the true region, correct? Or solution. So you can actually go ahead and regular shading, right? True area is shaded. That's what that tells you if it's regular shading. Okay, so now let's do this one first. We know this is going to be y is greater than, and no equal because it's dashed, right? So that's a mark for this part. And then I'll give you another mark for doing the second part. So this is, what's the slope here? That's your intercept. And you scan the line. You think you might be here, but I don't think so. I'll go here. So if there's a point, use that one. Okay? So this is 1, 2, and then 1, 2, 3, 4, 5, 6, 7. So it's 2, 7. And it's dropping from left to right, so it's negative 2 over 7x plus 3. Okay? So that's what the inequality is for this graph. So 1 mark for the first part and 1 mark for the second part. So any mistake on the second part, you lose a mark. But you at least get 1 out of 2. Okay. Next we have the, let's do line A here. That is just x, and true region is to the right, and it's a dashed line, so you just do this, and it goes through 3, 0, so it'd just be x is greater than 3. 1 mark for that. This one is a horizontal line, so it'd just be y, and it's below the line, so you go less than or equal to because it's a solid line, and it goes through -2 here. So that's what the inequality looks like there. So 1 mark, 1 mark. That's how you get your 4 here. Okay? What are we at here? Hold on. 3, 4, 5, 6, 7, 8, and 4, that's 12. So this page is worth 12. So just go to the top, enter it there, name and last name, and I'll take that. And then we'll continue with our note.